All right, so this is our first video on friction, static or kinetic friction. So the question is, a force of 42 newtons is needed to start a box sliding across the floor. The weight of the box is 55 newtons. Draw all the forces acting on the box. So I'm going to just underline some things, some key things that we can use to answer this problem. So to start, the weight of the box is 55 newtons, and that applied force is 42 newtons. All right, so essentially we have someone pushing on a box and it hasn't slid yet, and we want to know the weight, and we want to draw all the other forces to answer. How large is the force of friction? Is the frictional force static or kinetic? What is the coefficient of friction? And I'm going to explain what these things are once I draw the forces. So the free body diagram of this box is going to be gravity pointing down, and gravity is also considered as weight, which is a capital W. We're going to have the opposing force normal, which is the opposite of gravity or the weight. And we have, let's say that the applied force is being pushed to the left. All right, and that is force applied, force app. And then we have the opposing force of force app, friction. And that's lowercase f. And we have to assume now that this is probably going to be static. And I'm going to explain what that means, static friction. All right, so how large is the force of friction? All right, so they're asking us what is the numerical value for this force here. All right, so we first want to find the overall numerical values for all the forces on it, and then we're going to solve for the frictional one. All right, so they tell us that the weight is 55 newtons. So we know that gravity is 55 newtons. And because it is pointing downward, it's going to be negative because force is also a vector. All right. Now, if the gravitational force is negative 55 newtons, because its opposing force normal is pointing up in the opposite direction, it's going to be the same value, but just positive 55 newtons. All right. So we have the values of the two vertical forces. What are the values of the horizontal forces? So they tell us that a force of 42 newtons is needed to start a box sliding. So we assume that the only force, if hypothetically speaking, that is pushing on it is going to be 42 newtons. And the key word is start. Start a box sliding. So that means that the box has not moved. So that tells us something about the friction. So friction itself is either going to be static friction or kinetic friction. And static friction just means friction that the opposing force that before objects begins to move, that force that is keeping it from moving for a certain period of time. And then kinetic friction is that frictional force after the box or any other object starts moving after you're pushing on it for a long period of time. And so that's the difference. And because our box has not moved, we're dealing with static friction. All right, so let's go ahead and solve for it. So we're going to start with our F net X, which is the total forces in the X direction. All right, so the total force in the X direction is going to be negative FAP. or force applied, which is pointing in the negative direction, left, plus the static friction is positive because it's pointing in the right direction. All right, and let's go ahead and put the values in. So the total force in the x direction, because the object is not moving, is going to be 0, equals negative FAP, which is 42, so it's going to be negative 42 newtons, plus the static friction, which we don't know. All right, so I'm gonna bring this equation up here a little bit so you can have more space. So we have essentially 0 newtons equals negative 42 newtons plus the static friction. All right, so we have a number, and a variable. So this is a one-step equation. So we're going to solve for friction by adding 42 newtons on both sides. The right side crosses out. So the static friction value is going to be positive 42 newtons. And this makes sense because the object has not moved, but it has an applied force on it. So that means that that force, that applied force that is being pushed on it, is equal but oppositely proportional to the friction. So essentially, it's the same value until it starts to move, and that value is 42. So that's how big our friction is: negative 42 newtons. Excuse me, positive 42 newtons. All right. Now, is the frictional force static or kinetic? Is the box moving? Is the box not moving? The box is not moving, so the answer is going to be static. All right. And what is the coefficient of friction? What is the amount of stiffness on the surface? That's what they're asking. What is the amount of stiffness or rigidness on the surface? All right. So this is just a simple equation. Static friction equals mu s times the normal force. All right. So we know that our static friction is 42 newtons equals our mu s, which is our static frictional coefficient, and our force normal. We said our force normal was 55 newtons. All right, and so again, this is a one-step equation. So this is multiplication. So we're going to divide 55 on both sides. The right side crosses out. So therefore, the static frictional constant or coefficient of friction that's static is going to be 0.76, and this is just the coefficient, so it doesn't have a unit, it's unitless. So that is the coefficient of friction of the floor, and that's pretty high. That's very stiff, very, very stiff. All right, so just to conclude everything, this is a static frictional free body diagram, meaning that we have an object that is essentially being pushed on. It has this force that is being pushed on it, but it's not moving because this frictional force that is opposing it, which goes in this direction, because friction goes opposite, is going to be equal but opposite of the supplied force here. All right, that's what static friction does. It's going to be equal and it's going to go up, it's going to go up, and then eventually it's going to get its maximum frictional point and it's going to turn into kinetic friction. All right, so this problem is a static frictional free body diagram, and we just found the value of it and the coefficient of friction. Thank you. Goodbye.